In this video, we're going to investigate a couple of questions that will lead to two very important lemmas about ring homomorphisms. So we're going to start by letting phi be a ring homomorphism from ring R to ring S. So we have a ring homomorphism. And now I want to ask a question. And my first question is going to be, what can we say about phi of the zero element in ring R? Well, let's actually investigate this. And what I'm going to notice is this. So we're going to start this way. Inside R, we actually know that A is always equal to A plus 0. And so what that's going to say is that phi of A is going to have to be equal to phi of A plus 0 inside of S. So I'm going to want to make a distinction between my 0 elements. Those two zeros are both living in ring R. But now phi is a ring homomorphism, so this last thing says that phi of A is equal to phi of A plus phi of the 0 element in R. And this is still an equation inside ring S. Now, because ring S is a ring, I know that there is an additive inverse for this particular element, and I'm going to add that to both sides of my equation. So let's put that in a different thing. So we're going to say that we are going to add minus phi of A to both sides. And so we're going to add minus phi of A to this side. And that will have to be minus phi of A plus this side. And this is still an equation in ring S. And I'm going to use the associative property to put some parentheses around these two elements on the on the right-hand side of my equation. And the stuff that's in these two sets of red parentheses is the additive inverse. So this is the additive inverse in ring S. So our next step becomes that we have the 0 in S is equal to the 0 in S plus this element of S. Now, any element in S plus the 0 element in S is just the other element. In other words, the 0 in S plus this weird element is just going to be this weird element. So what we now have is that this chunk here can be rewritten as phi of the 0 inside the ring R. And let's take the time to actually look at what we've now shown. What we've shown is that the 0 in S is actually equal to phi of the 0 in ring R. In other words, we have proved the following lemma. And it's a very important lemma. And this lemma states, if phi goes from R to S is a ring homomorphism, then we know that phi of the 0 element inside R is always going to be the 0 element inside S. What we can think about schematically is this idea. Here is R, here is S, this is 0 inside R, this is 0 inside S, and one thing that I definitely know now is that phi is going to take the 0 in R to the 0 in S. Oops, it's to the 0 in S. Well, now what I want to do is turn my attention to a second question. And our second question is going to be this. So our second question Again, we're going to start with a ring homomorphism. Now, this time, what our question is going to be is this. I'm going to start with any element inside the ring R. And what I want to ask is there a relationship? So is there a relationship between phi of A and phi of minus A? Where minus A, of course, is the additive inverse element for A. So this guy plus this guy is equal to 0 inside the ring R. So I'm really wanting to know if I know something about, so schematically what we're looking at is here is R, here is S, here is A, and here is phi of A. And I'm going to say that I know that phi sends A to phi of A, and then I've got an element over here which is minus A, and I'm really wondering, where does minus A wind up under phi? And so let's actually investigate this particular question. So we're going to get started in this particular fashion. We're going to make a note that A plus minus A is known to be the 0 element in R. And so what that tells me is that phi of A plus minus A is going to have to be phi of the 0 element. Now this equation is over in ring S. But we just got done showing that phi takes the 0 element in R to the 0 element in S. So I know that phi of 0R is equal to the 0 in S. On the other hand, over on this side, I can simply apply the definition of a ring homomorphism, and I can break that side up into phi of A plus phi of minus A. And this is an equation inside S. Now here again what I'm going to do is I'm going to add the additive inverse of this element inside S to both sides of my equation. So let's see, what am I going to do? Let's put this in a different color. We're going to look at minus phi of A, and we're going to add that to both sides. So minus phi of A. And then we have to write the rest of this. So we have phi of A plus phi of minus A. And then on this side we have plus the 0 inside S. So I simply added this element to both sides of my equation. Well, again, what I want to notice is that ring properties come to the rescue and tell us a lot of information. The stuff inside these red parentheses over here is going to simply be the 0 inside of our ring S. So we have 0 in S plus phi of minus A is equal to, well, over here on this side, this anything plus the 0 in S is just going to be this anything. So I'm just going to write that down as minus phi of A. But then that same property comes into play a second time. This side here is just going to be, it's 0 plus anything, so it's going to be the anything. So the left-hand side now becomes phi of minus A, and the right-hand side is minus phi of A. In other words, a ring homomorphism takes additive inverses in R into additive inverses in S. So I want to kind of make that clear. This is an additive inverse in R, and when I apply phi to that, I get an additive inverse in S. Well, again, I want to state this as a formal lemma, so we're going to state this as a lemma. And our second lemma is going to say if we have phi is a ring homomorphism, and we look at A inside set R, then phi of minus A is just going to be minus phi of A. And this is going to be true for all A's inside our ring R. Now, to go back to that schematic picture for just a minute, what this basically means is that if we have R here and S here, and we've got A and minus A over here, then what I know is that wherever phi takes A, phi also takes minus A to the additive inverse of phi of A. And so that's what this particular theorem says. To tie this particular video up, I simply want to state a summary. And so in summary, we have proved two important lemmas. And these two important lemmas say the following. The first one says, if we have a ring homomorphism, so let's let phi go from R to S be a ring homomorphism, then phi of the 0 inside R is the 0 inside S. And the second one says, if we let phi be a ring homomorphism, then for every A inside the ring R, we have phi of minus A is minus phi of A.